So just to review, remember that inductive reasoning is using your past experience to draw a conclusion. We talked about that and we looked at several examples in the last presentation. We also made a point of saying that the conclusion that you draw can be correct or it can be incorrect. It can go either way with inductive reasoning. So a counterexample is going to be an example that proves that your conclusion is incorrect. So let's say that I claim that all animals have 4 legs. So in other words, I come to you and I say, all animals have 4 legs, and you don't think I'm right in saying that. So I ask you why not? And I ask you to come up with what we call a counterexample. Can you think of an example of something that makes my claim incorrect? In other words, can you think of an animal that doesn't have 4 legs? Well, there are actually a lot of counterexamples to that. Okay, there are people. People are animals, but they don't have 4 legs. There are fish. Fish are animals that don't have 4 legs. And there are spiders. Spiders have 8 legs. So if I tell you that all animals have 4 legs, you could give me any of these examples as a counterexample. And in doing so, you have proven that my claim is incorrect. So what if I change my claim and I say now that everything with 4 legs is an animal? All right, can you think of a counterexample? Can you think of an example that proves that my conclusion is incorrect? Can you think of something with 4 legs that is not an animal? Well, this one's a little bit harder, but what about a table? It has 4 legs, but it is not an animal. And so a table is a counterexample. If I say that everything with 4 legs is an animal, and you say, no, you're not correct because think about a table, then you have just given me a counterexample. Let's try a few more. All right, so let's say that the claim is that all birds can fly. And I want you to give me a counterexample. So you need to think of a bird that cannot fly. All right, well, that is possible. One example of a bird that cannot fly is a penguin. And there are others, but that is one counterexample. All right, what if my claim is that the name of every United States state includes the letter E? Well, you could say to me, no, I don't agree with you because, let's see, the state Ohio does not contain the letter E. That's a counterexample to my claim. The next one says the sum of 2 prime numbers is prime. Okay, so you may need to remember that a prime number is a number that the only things that can divide into that number are 1 and the number itself. So, for example, 3 is prime because the only things that will divide into 3, you can divide 1 into 3 and you can divide 3 into 3, but nothing else. So that's a prime number. Another prime number is, say, 5, because the only things that divide into 5, 1 divides into 5 and 5 divides into 5. Okay, so my problem here says the sum, which means that I'm going to add, the sum of 2 prime numbers is also prime. So the sum of these things is going to be 8. Is 8 a prime number? No, 8 is not a prime number because 1 divides into 8, 2 divides into 8, 4 divides into 8, and 8 divides into 8. So it is not a prime number. So if I come to you and say the sum of 2 prime numbers is prime, you can say, no, it's not, because 3 plus 5 is not a prime number. All right, let's do a couple more. What about this one? If the claim is that when an even number is added to the product of 2 odd numbers, the result will be even. Okay, so let's just pick some numbers and see if we can prove that this is not true. So I need an even number, so maybe 2. So when an even number is added to the product, remember product means multiplication. So the product of 2 odd numbers. So let's come up with 2 odd numbers. What about 3 and 5? Okay, so that is 2 being added to the product of 2 odd numbers. All right, so let's work that out. So the product of the 2 odd numbers would be 15, right? 3 times 5 is 15. And when we add the 2, that's going to give me 17. And 17 is not even. So that makes it a counterexample because the claim said that if I took 2 and added it to the product of 2 odd numbers, I should get an even number. And you're saying, no, that's not right, and here's an example of why it's not. All right, what about the next one? The sum of 2 odd numbers is odd. All right, so pick 2 odd numbers. What if we pick 5 and 7 and we add them together? That would give me 12. 12 is not odd, so that is a counterexample. If someone tells you that the sum of 2 odd numbers is odd, you could say, no, it's not, because 5 and 7 make 12, and it is not odd. All right, and our last one says if A is less than 1 and B is less than 1, then A times B is also going to be less than 1. Okay, so let's pick a couple of numbers and let's see if this is true. So I need a number less than 1. Let's say that A is going to be -3. And B also needs to be less than 1. So let's make B equal to fix that real quick. All right, so we'll make B equal to maybe -4. All right, now I need to multiply A times B. So -3 times -4. And remember that a negative times a negative is a positive, so that's going to be 12. And 12 is not less than 1. And so there's my counterexample for that. So you want to remember that if you're asked to find a counterexample, you are finding an example of something that doesn't work. You are proving the claim false by giving an example of something that is not true.